Assalamu alaikum. We're going to start now. Before we start, I have an announcement for all of you. Let me first just share the screen. Okay. Basically, KEU renewed the Matlab license. Okay, so basically you can create an account at MathWorks with your KEU email, and once you do that, basically you can download the full version of Matlab. And you can also download any version actually, basically, but now the current version is 2020B. Okay, so please do that. This is actually very important because you will need it not just for this course, but for your thesis later on. Okay, so please do that. Okay, so this is a bit too late because we wanted to have that at the beginning of the term, but actually you will need it, you'll definitely need it in your thesis work, okay? And the other courses, okay? Do you have any problem? Do you know how to do that? Do you know how to download from MathWorks? Did you try it before?
Do we need to use 2020B, or we just use the late?
No, any version will be fine. Any version will be fine. But I mean, this is a full version. This is a full Matlab version. This is the legal version. Okay, this is not a cracked version. So basically, this is a good thing to have. Not for this course. Basically, if you're comfortable with the version that you're using, that's fine. It's up to you. But you need to download it at some point because you will need it later on. Okay, and maybe by next term, something like that, maybe in February or March, you will have the 2021 version, 2021A version. So basically, you have with this license, you can actually whenever a new version of Matlab comes out, you can download it and install it on your computer. Okay, so this is a very good thing. It's a bit late, but it's a bit delayed. We wanted to have that maybe a year ago or something like that, but actually it's not bad to have it now at least. Okay. So basically, this is very important, not just for this course, for your work, for your thesis work in general, okay, and the other courses, of course. So please do that. If you have any problems, please let me know. But you have to create an account with your KEU email. Once you do that, basically, you will find the license. The new license will be there, okay, and you have the option of downloading it from your account. And whenever you install it, you put your account. You basically activate the Matlab with your account, your KEU account on MathWorks. Okay? So you all know that now, right? Okay, this is very important. For today, what we're going to do is I'm going to show you another option for basically selecting a classifier using what's called Classifier Learner App. Basically, what we had before from our code, basically, we had features, we had feature selection, we had classifiers, and basically when we run it, basically it's gonna create models for these classifiers as we see here. We created several models, and then we used one of them and basically got the results as you saw here. We got like accuracy of 95 point something here, which is good. Some of them actually 97 actually. So basically, if you wanted to optimize the classification or you wanted to use another classifier. As we saw from the help of the classification functions, each one of these functions, like for example, fit, seek, and let's see the help. You have several options. You have actually many options sometimes, basically. You have several variables here, and basically depending on the variables that you have here, you have basically, or the name values here, you have several options to choose from. Let me show you what kind of options we have here. So basically, there's something called type breaking algorithm. If you're using something that has an even number of neighbors, okay? If you, for example, chose 4 neighbors instead of 3 neighbors, and you have 2 classes, and you ended up with a tie, okay? You have two neighbors from class 1 and 2 neighbors from class 2. Okay, what should you do to do that? What should you do to basically choose which one is the dominant one? Okay, this actually, there's something called type breaking algorithm that actually works by looking at these neighbors and choosing the class of the 2 neighbors that are the closest. Okay, there are several algorithms actually, but this is one of them. There's basically, let me see here, there's a cost for misclassification. Basically, if you're trying to choose or basically try to compute the cost of the misclassification, okay? We have, as we said before, we have for the confusion matrix, we have several, we have basically true positive, true negative, and false positive and false negative. And what we said was, there's a difference between the false positive and the false negative, basically, okay? The false positive is definitely, basically, it's incorrect, but it's actually less harmful to the patient from the false negative. Because the false positive, you told someone who is normal that he has a problem, okay? He's gonna do further testing, but at the end, he will realize that he's normal. But for the other guy, for the person who has the disease, and you told him that you have no problem, you're normal, this is going to be a problem because he's going to go home, he's not going to worry about that, and basically will come later on after the disease became spread in his body, and basically it might be harmful or even sometimes it can be actually life-threatening. So basically, this is dangerous. Basically, you can choose that also as well. You can have a distance metric. Distance metric basically is how you're going to compute the distance to the neighbors. Okay, there are several options here. One of them is the Euclidean distance. Euclidean distance is what you normally use before to compute the distance, but there are several other distance measures. Okay, one of them is the city block distance, which is the 1 norm. Okay. Basically, for the 1 norm, let me show you. Basically, if you have, just imagine this grid actually as a point where you're trying to measure the distance. Basically, I'm trying to measure the distance from point 1 to point 2. I want to measure the distance between these 2 points, okay? If you imagine that these blocks are actually city blocks, like you have streets, this is like a street, and this is another one, this is another one, and this is also, you have a grid of streets, okay? If you're going to walk from point 1 to point 2, how can you do that? Can you go right there? Can you go like this? If you have like streets that are like this, okay? I want to go from this point to this point. Can you go like this?
No, we cannot.
You cannot. How can you do that? You have to actually walk along the streets. So basically you have to walk like this here, and then like this here, right? This is basically one type of norm. This is what they call city block norm. Or sometimes it's what they call it 1 norm, okay? Or basically it's a kind of distance, okay? So basically there are several measures like this, several distances measures like this. City block is one of them. So basically the point I want to make here is that we have so many options. Basically, see for the distance metric, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 functions, 11 different options for just one parameter in this classifier, okay? So it's very difficult to try to optimize. If I told you to choose, if you're trying to get the best classification out of your data, okay, you probably have to try all of them just to make sure that you got the one that had or gave you or provided the best results, right? So basically, it's a tedious task. For each one of the classification methods, you have to do that. You have to go through all the options and choose from them. And this is not something that you would like to be doing. Actually, it's going to take a lot of time, and it's just tedious work, okay? So basically, Matlab, they try to help people who are doing work like this by having what's called apps here. Like the one we used last lecture for the deep network designer. We used that last time. Okay, so basically there is another classification learner app that is really useful. First of all, did you all try the deep network designer on your computers? Did you have any problems with the deep network designer? Okay, no responses. I assume that everything was perfect. Okay, that's fine. If you have any problems, just let me know. Okay, but for the classification learner, it's a much simpler app. It's much faster app because usually statistical classification is much faster than neural network or deep learning algorithms. So in this classification learner, basically, you're going to specify the data and you're going to have all kinds of classification methods at your disposal, and you can actually optimize the parameters of each one of them, okay? Let's focus now on the task of just trying several of them, okay? Just trying to, basically, we talked about the SVM, we talked about the K nearest neighbor, we talked about maybe naive Bayes in the lecture, but we didn't try it. Actually, let's see what we have here, our code. Let's just close that. Here we have KNN and SVM. Basically, we use KNN and SVM only, okay? There are other families of classification methods, okay? So we would like to try them, but all of them actually have a function that fits them and a function, the same function, predict to use the model that we created using the fitting and get the results from the testing data, okay? Here in the classification learner app, basically what you're going to be doing is exactly that. Basically, I'm going to start a new session and I'm going to say that I'm going to use the data from the workspace. Basically, if you look at the workspace that we have here, let's look at the code first. The data that we have, we basically have the learning data here in X and Y. Okay, sorry. X and Y have the data, and XT and YT have the testing data. So basically, for now, I need only the learning data, okay? I just need a set of data, just basically features and labels. That's it. Okay. So basically, since they are in the code, they are here in the workspace. Basically, I have X here. It's 100 by 13 because we have 50 normal cases and 50 abnormal cases, a total of 100 cases, and we have 13 features. After we did the feature selection, and we have their labels in Y, which is 100 times 1, which is basically, let us list it here, let's just look at it. We have zeros and 1. We decided that zeros would represent the normal cases and ones would represent the abnormal cases. So we have them right there in the workspace. So basically, what I have to do here is just select the variable, basically. I have here all the variables in the workspace. I'm going to look for X. This is X right there. It gives you two options. Sometimes you have the responses as the last row, as the last column in your data. So basically, it assumes that you're going to take the column number 13 from here. You have here 100 by 13. Some people actually like to have one variable for both, for the features and the label. Okay, so it assumes that the last one would be for the labels, but actually this is not what we have. So I'm going to say that the response, which is the label, okay, will be from workspace also. Once I do that, it looks for a variable that is 100 by 1. It found it in Y. Okay, if you have multiple variables with the same dimensions, basically you have to select the one that would represent your Y, basically your actual labels for your data. Okay, and you have here several options: cross validation, holdout validation, no validation. Let me give you an idea about what all these mean. Okay, basically we have a data set. Let's hold. I have a data set that is kind of small. I have a small data set. I have X that is basically, this is basically here that this dimension is cases and this dimension here is features. But let's assume that the number of cases here is small. Okay, like what we have. Basically, we have the number of cases in our training data set is 100. 100 compared to the cases or the basically the number of samples in another problem that is not biomedical, basically in the classification of faces, classification of fingerprints, things like that, you probably have millions of cases. Okay, here we have only 100. If we try it to basically, as we said before, we have to divide that into training and testing. Okay, so basically I have to divide that somehow. I have to have training and I have to have testing. Okay, and basically once you do that, this will become a little bit smaller. Basically imagine that you're trying to learn from 50 cases, only 50 cases. Okay, 50 cases is a very small number to learn from. Sometimes the very small number might not have enough cases to represent the variations in the disease that you're trying to classify. So basically, you would like to have a scenario where you use the maximum number of cases in your training. Okay, so basically you want to have, for better model, you want to have the maximum number of cases for training. The model. Okay, so basically, if you want to do that, if I have 100 cases, what is the maximum number of cases that I can use? Can you please answer? I have 100 cases. How many cases? What is the maximum of training cases that I can have? How many cases maximum I can have for training? Just give me what you think. It doesn't have to be exactly what I want.
75% of the total number.
75%
of the total number.
Okay. No. Okay. Let me give you an idea about this. Can we take all the 100 cases? Can we take all of them?
No, we can't.
What would happen if I take the 100 cases? Actually, the 100 cases is the best scenario, basically. It's gonna basically train on so many cases, and basically it will give me the model that will be trained with 100 cases is gonna be probably the best model that I can have, right? Because it has the maximum number of training cases, okay? But what is the problem of having all the cases assigned to training?
No testing or cases for testing.
Yes, right. So basically, question, why not 100? The answer is no testing. Okay, regardless of your model, model would be better than any other model. But the problem is I need to know whether this model would be enough for practical use or not. So I have to have testing. So basically, if I use 100, that would not be a good idea. Okay, so this is not acceptable. The other question is, what is the second best? What is the second best number of cases? Why not 99? In this case, you have one testing sample. Is that enough? What is the problem of that? Basically, the problem of having only one testing sample is that the result will be either 0% or 100%, right? It's just one case, basically. If the model correctly classify this case, it will give you 100% because one case out of one was correctly classified. If it wasn't classified correctly, it's 0%. Does this make any sense? This is not acceptable, of course. Okay, so basically the idea of cross-validation is that you're going to repeat the training and testing using large training sets. Okay, and tests with a few samples in each time. This would be a problem still. Even if I have 5 samples, it will be basically either 0, 20, 40, 60, 80, or 100. This is not acceptable. I have a step of 20%. Okay, so basically what you're going to do is you're going to repeat that n times and average. This means that if you have, for example, if I use this case here, which is basically one of the very well-known methods, there's one very well-known cross-validation method. It's called leave one out cross-validation. Leave one out cross-validation. Okay, if you have 100 cases, what you're going to do is as follows. Iteration number 1, you're going to use first 99, or let me put it exactly like this, from 1 to 99 for training and 100 for testing. The case number 100 for testing. Then iteration number 2, you're going to use from 2 to 100, and you're going to use 1 for testing. And then you're going to iteration number 3, you're going to have 1 and 3 to 100, and you're going to test with 2, and so on until you finish all of them. And then average all of them. How many times can you do? What is the last number here? How many times can I do that? The last one here would be 100, because you're going to leave 1 each time. So each one of the 100 cases would be left at one of these iterations. So basically you're going to have 100 iterations. When you average them, you're going to get a ratio like 93.2, whatever, 95.1, whatever, because you're going to average 100 and 0 over a large number. So basically you're going to get something that is very close to what you would get from a larger data set. Okay, so basically you're going to get basically it's a solution for smaller data sizes. So you can get a model that is trained by the maximum number you can get, and basically still get a result that would be actually like as if you have a large data set for your testing. In this case, actually, the testing would be as if you have 100 testing cases. It's basically as if you doubled your data size, which is a very excellent. The cross-validation in general, when I say that I have, the term is I have n-fold cross-validation, like what we saw in the interface. It's basically if I have, for example, 5-fold cross-validation, I will do that. In the first one, I'll take 80%, and the other one testing. Basically, the training would be like this, and the testing would be like this. And the second one, I take another 80%, a different 80%. So each time I have a different 80%, a different 20%. So this 20% can be here, the first 20%, and here the second 20%, here the third, and so on. And you do that 5 times because it's 5-fold. Okay, you can, each time you have different testing data. And basically, if you have 20%, if you have 5-fold, then you divided your data into 5 folds, basically, and each time you use a fold for testing, and the remaining data will be used for training. And then I average all of them. So this is very effective, actually. And basically, if you have data like this, you can just use it and basically get the results for validation and consider it as close as testing data or testing results. So what we have here in the new session, we have cross-validation. Holdout validation is exactly like basically like the n-fold cross-validation, but basically you take the data only, you just take one of them, take one fold only. If I selected holdout validation, basically it will hold 25% of the data as testing data. It's basically the regular thing that you have been doing, basically. Okay, and basically takes that and use it for testing as an independent testing. Okay, so basically we train with 75% and test with the independent 25%. You don't repeat that. No validation basically is not a very good option here. What you do is you train with 100% and you test with the same 100%. Okay, this is not a good idea. Okay, you would end up with something called overfitting that we talked about before. Okay, so you will get very high results, basically like 100% accuracy, something like that. But when you try to use your model in different cases, in cases that are different from the training cases, you'll end up having very bad results. So the option here, the good option here is have cross-validation. 5 folds is okay, because we don't want to have too much time in each training, basically because it has to be repeated that many times. So just keep it as 5, but you want to increase it, you can do that. Basically, the maximum here is going to be have 50 folds. Actually, you can do a little bit more, but actually 50 folds, you just have 2 cases for the testing. Let's just have it as 5 folds. And basically, once we do that, we selected the data, we decided what we're going to do, how we're going to do the training with the data, and basically we're ready to start the session. Okay, so basically we have the session here. All we have to do is, here you have all the classification methods that you have in Matlab, all of them, all the different families, okay? Have the decision trees. We even didn't talk about the decision trees, okay? It's already there. You can use it without even knowing what it is, okay? You have something called discriminant analysis. You have something called logistic regression. You have naive Bayes. You have support vector machines and the k-nearest neighbor that we used before. You have different options for each, by the way, and you have an optimizable, for each one of them, you have an optimizable classifier that basically works to change the parameters so that you can get the optimal performance out of each one of them. At the end, you have something called ensemble classifiers. the ensemble classifiers are basically very good when you have very unbalanced data. For example, usually for biomedical data, you have so many normal samples more than the abnormal samples. This is the usual case, okay? If you basically selected basically all the people in Jeddah, for example, okay, and you wanted to test them or get samples from them for diabetes, for example, okay, you will have many more people without diabetes than those with the diabetes, okay. Basically, you don't expect, or basically you can say the same thing about breast cancer, for example, the screening breast cancer. The screening for breast cancer, the disease prevalence is less than 1%. So basically, you have a very small number of cases that is abnormal relative to the normal. So the ensemble classifiers, if you have data that is significantly imbalanced, they have several methods to try to basically to work with that. Because if you present it to the classifiers 1,000 cases of abnormal conditions and 10 cases of normal, the other way around, 1,000 normal cases and 10 cases of abnormal cases, you will end up having a classifier that is severely biased towards the normal cases. Okay, basically, if you have a classifier, basically, if you at the end of the training, actually, you will tend, basically, the classifier will tend to classify all cases as normal. If it does that, the accuracy for it is going to be 99%, because basically, if you compare the 1,000 cases to the 10 cases, even if you have all the 10 cases inaccurately classified, basically, it's going to be just 1%. Okay, so basically, it doesn't make sense to train data with imbalanced data, train classifiers with imbalanced data, but ensemble classifiers can actually handle that case. At the end, you have so many different classifiers. Let's just select one of them. Maybe we can select the cubic SVM, okay? All we have to do is just say train here, okay? Okay, it's gonna start the parallel pool. If you have a parallel pool, basically it prefers to do that so that it finishes things quickly. So whenever it finishes starting the parallel pool here, it's gonna start computing the results. Still opening. It takes about 30 seconds at the beginning, and then basically after that, you don't have to do that again. Okay, so it's queued now, and it's training. The accuracy 98%. If you remember from what we got in Matlab from last time, the best result was 97.7. So basically, the first one we got here, we got the cubic SVM that gave us better results. Okay, so this is good actually. This is not bad. Okay, so we can actually train several classifiers like all quick to learn or quick to train. Basically, it selects all the different classifiers from different types that are basically that train very quickly, so that you can get some results, just get a feel of what the numbers are in your classification or your problem with your data. So basically, it's going to compute each one of them, and basically it gives you the best. The best one will still be highlighted like this. So basically, you classify 3 and k-n of different methods, and you can also say all linear. So basically, it's going to try the linear option for each one of the different classifiers. So also, it's going to, now we got some good results here. Linear discriminant is about 98%. And the SVM also with the linear option was 98% as well. So that's, so the thing with, yes, go ahead.
I want to ask you about or after that, can I know what's the parameters selected?
Yes. Basically, for example, this one here, linear discriminant, okay? I would like to now use that linear discriminant function, or basically whatever I got from here. When you stand here, you have all the options here listed, okay? So basically, the model type is linear discriminant, covariance structure full. If you have another one that like the SVM has more options. See here, you have all the options for the SVM right there. So you can select them, or you can write them yourself from here. The easy way to do it is to generate function. There is a a part here that's called generate function. It's going to generate a training function for this particular classifier. Okay, the SVM, the FedCS VM, what we used before is right there. This is a function that you need right there. So I can just copy that from here and go back to my earlier code and just insert it there. I can put another one here. Maybe I can just call it model 8 or something like that. Okay, that is like that. But actually, you have to predictors are the X, and responses are the Y, and that's it. Give you the results right there. So this is very convenient, actually. So instead of trying to think about all these options, it basically, you try them visually here, and then you go here and generate the function, the training function, and get the training function from either the model fitting from here and use it in your code. The nice thing also is that you can get the confusion matrix right away, right there. Okay, this is the confusion matrix. Once you get the confusion matrix, as you know, you can compute basically here you have 0 is the normal and 1 is the abnormal. So basically when you have 1 and 1, this is the true positive. 0 and 0, this is true negative. This is basically true classes right there. So basically this is a false positive here. Okay, and this is the false negative. Okay, can you see that? So basically now you selected the, you basically have the, you have the confusion matrix, and I can use it to compute all the performance metrics that we talked about. You can have something called the ROC curve that we talked about before. The area under the EOC curve, the ROC curve actually is called area under curve. The larger the area here, the better the classifier. Okay. So basically, ideally, you need to be at this point right there because it's basically true positive rate against the false positive rate. Basically, one of them is true positive is the sensitivity. The false positive rate is the 1 minus specificity. Okay, so basically here you have a specificity of 100% because basically the false positive rate is 0. And the sensitivity is 96%, which both of them are excellent. Okay, so you can generate the covariance matrix figure. You can actually export this to a figure here. You can just have this as a figure, and you can save it to JPEG if you want to include it in a report or in a paper or something like that. Okay, you can just have it as JPEG if you want to, and any type of image format that you want, and just save it like there. And you can do also that for the ROC curve. Same thing. You can generate a figure out of this and include it in your report. You can actually go back and basically, if it's not only for the last one, I can go here, just select that here and get the results updated for that. So now see here, for the linear discriminant, we have 1 and 1 instead of 2 and 0. This is different. Okay. They have the same rate, but actually, if you gotta compute the sensitivity and specificity, is gonna be different. Here, if you look at the ROC curve, here it's 0.02 and 98. So basically, the specificity will be 98%, the sensitivity will be 98%, instead of 100% and 96%. Actually, this might be a better classifier, actually. Okay. The other one would be, actually this one is better classified because here the sensitivity is higher. So you have less false negative. This is the false negative. Okay, the false negative should be as yes, this is the false negative. Actually, the other one would be better in this case, actually. So this is true class 1, and yes, basically you don't want to have that. It's better to have 0 and 2. You need to have the false negative. The false negative, you need to have it as minimum. There is one more thing you can do actually is that instead of having the Classification Learner App, it basically optimizes the cost. So basically it tries to minimize the cost. But here it puts the cost for this error is exactly the same as this error. This is the true class, and here basically you have false negative. This is true, this is abnormal case, and you classified it as normal. Okay, so basically this is a problem. This should be actually with a higher weight than this. Basically, you can just put that as 2, for example. Okay, if I put it like that and repeat the training, it's going to be different. Basically, if I do that to a particular training, it's going to basically create another classifier to be trained right there. Okay, so right now it tried to optimize. Sometimes it doesn't really reach a better optimization, but sometimes it does. And basically it keeps minimizing this option here or this number here because you have a higher cost for it. Okay, so basically the classification cost might be actually one of the things that you need to change in order for you to reach a particular conclusion or a particular result out of your classification methods. Okay, so basically what I wanted you to do in the assignment is basically use this app and try different families of features, basically different families of classifiers. You can probably SVM, you can choose nearest neighbor, and you can choose, for example, discriminant analysis. Okay, if you want to optimize the parameters, I can, for example, go to optimizable KNN here, and basically I can run it and see what happens. If you want to optimize the parameters, you can tune here. These are the parameters that will be tuned. Okay, all of these will be changed to reach the one with the best set of parameters, and you can choose the optimization, how it's going to happen. Here it's going to try 30 times. There are several optimization methods. You just choose one of them. It doesn't matter. Okay, and there are options within each one of them. These are optimization methods. Okay, so basically, if I run this, if I train this here, it's gonna start and show me here minimum classification error plot. It's gonna show me how the error changes with each iteration. Okay, so basically now it's about 0.06, which is about 94% accurate. Now it became a little bit better, and it keeps changing the parameters so that you can see which one would give you the best classification results, classification accuracy. It's gonna try 30 times. You can make it less or make it more, it's up to you. Sometimes when you use a particular family, you can actually get a particular result from here. This is the best result you can get out of this family. But you can actually, as you see here, the best result that you got for this was 97%. 97% is definitely better than any of the KNN session that we tried before. Okay, we can try the same thing. We can go here and choose SVM, optimizable SVM. Let's see if we can get better results than the one we got here. So it's really fun to use it, actually. It's much better than trying that with the command line option like the code here, because it's very difficult, kind of very difficult to actually go into the code and change things. It's much faster to do that in the Classification Learner App. So let's go back. Now we are at 0.02, so basically we're close to the 98% that we got before. See here the parameters that are changing, okay? The kernel function changes, linear, quadratic, and so on. You standardize the data. Standardize the data means that, of course, we have different features, and each feature has a different range, okay? Some features have very large numbers. Some features have very small numbers. So if you combine them in something like KNN, for example, the distance measures will have a problem because it will prefer the features with large numbers. So when you standardize the data, you get the data from all features and standardize each feature to, for example, between -1 and 1, or from 0 to 1, for example. Okay, when you do that, you basically make each feature dependent only on the changes. Here we have 98%. So basically, this was actually the best result that we got. So basically, so the standardization of it is a very good thing because it prevents bias coming out of having features with large numbers. Okay, so at the end, you can actually, instead of having the code, if you don't want to generate the function, you can export the model. See here the code. After each training, we have the code, we have the model right there, and we use it with predict. Okay, if you want to just get the model from the classification here, you can do that. You can export the model right away. Okay, when you export the model, it's going to create a model called trained model. And this, you can name it whatever you want. We can call it whatever, like our convention, MDL 9, for example, okay? So it's gonna be now in the workspace, MDL 9 right now, okay? So basically I can use it. It's basically exactly the same way we did the other ones right there. And we can use it with, it's a little bit different to get the outcome here. Use it like this, yfit equals to the model dot predict function. It's a little bit different from the one that we got from before. So basically, if I wanted to use that with Y testing, I can just copy that. Okay, it's not X now, it's XT, because basically we have the testing data, and basically we get the results out of it right there. If I wanted to get the results for XT, it's going to be like that, right there. So you have several options of using this interface, but the nice thing about it is that you can compare so many different families of classification methods. And each one of them, you can actually optimize with the different parameters that you have. Okay? Is that clear? You have any questions? Okay. One of the options here is PCA. Okay. PCA basically, you can enable it or disable it. Okay. If I, for example, decide to enable it, okay, then basically it has two options, either specify explained variance, or if I get the other options, specify the number of components, okay? So it's up to you to choose one of them. I'll just explain that in a second, okay? So basically the principal component analysis, let me write first about the standardization. Or standardization. Basically, I have a feature 1 that ranges from point 1 to point 2. All the values for normal, abnormal, everything. And actually, we have the normal between 0.1 and 0.15, and the abnormal between 0.15 to 0.2, which means that it's an excellent feature. Okay, this is an excellent feature. According to what we have been talking about, okay? So I have another feature that ranges between 10 to the power 6 and 10 to the power 8. Okay, this is the range of the values, okay? And you have the normal. The normal is between 10 to the power 6 to 10 to the power 8 over 2. And the abnormal is between, this is 6. The abnormal is between 2 So you have very heavy overlap. So here the curve would look like this. This is the normal, this is the abnormal, okay? Here it looks like this. Okay, very heavy overlap, okay? So this is not very good. If you use both features, if these features are put in a vector like this, the feature vector, or features for case number 1, or each case is going to be basically feature 1, feature 2. Okay, and basically whenever you try to compute the distance, it's going to be basically the delta feature 1, well, let's just call it F1. If you just compute it with the Euclidean distance, delta F2 square. And this is going to be in the range of 0.0 something. This is going to be in the range of 10, minimum of 10 to the power 6 or more. So basically, this will be basically insignificant. And this is not correct. This is the better one. This is a better feature. This is the less important feature. So the standardization basically works to take, or the normalization. Basically, if I have a normalization block like that, I have whatever each feature coming in, and basically coming out from either 0 to 1 or -1 to 1 or whatever, regardless of the input variable range. Okay, it goes out to a fixed range for each one of them. Okay, when you have that, then the difference or basically the importance of each feature will be basically based on the discrimination, not on the absolute value of each one of the features. Okay, so the normalization sometimes has a big effect, like in KNN, for example, which is basically, distance is very important in all classifiers, but in KNN in particular, because you're looking for neighbors and things of that sort, these will be very different. Basically, if you have something that is very large like this, it basically things like the other feature like that will be basically obscured. They'll be basically overwhelmed by any differences here, even though they are not corresponding to actual changes in the condition. So the normalization is very important. Okay, this is one of the options that change in the training, basically. The other thing I wanted to talk to you about is the principal component analysis. For the PCA. In summary, this is summarization tool. What does that mean? Basically, I'm going to remove redundancy. If, for example, I have my data, I'm going to consider just a two-dimensional example. Basically, imagine that your features are like this. Okay. the feature look like this. Basically, you already have your feature 1 here and your feature 2 here. And if you plot the data, they will look like this. Okay. You consider F1 and F2 as independent, but actually they seem to be dependent because each one of the features, they seem to be on a straight line like there. You can almost have an equation F2 is equal to AF1 plus B. You have a line like there, all the data line on that line. So basically they are dependent. Okay, how to remove that dependency? PCA basically looks at the directions of most variance. This is a very important term in this context, variance. For example, here you see here that this direction right there is very important because basically the data is spread along a very large distance in that particular direction. If you look at the other direction here, no, it's not. This is very large variance. This is not very large variance. Basically, the distance here, if you look at all the points here, basically they have zero variance in this direction. So the PCA comes up with what's called principal components. And they are sorted by variance, meaning that you have the largest first and then the smallest last. Okay, so the first PC1 is the largest variance. Okay, so basically if you look at the data like this, it would be actually very useful if we have basically if you rotate these features or have or basically come up with this direction right there and this direction right there, and basically you change your axes or rotate your axes in order for you to be along this direction and that direction. And basically you can ignore this direction altogether. So if you do that, then you have reduced your features from 2 features into basically just 1 feature. And this is basically PC1 here, and this is PC2. So this is very important. So in our example here, we have 13 features. Basically, what we have here, we have 13 features. If we choose 95% here, it will basically collect the variances that would represent 95% of all variance in the data. So basically, you got most of the variation explained by very few principal components. Let's try that. Let's try that on a simple case for, let's just try the one that has a quick, basically here I have the 95%. Let's just try that and see what happens. Here it didn't give very good results, but actually if you look at any one of them, see here, it used PCA. PCA is keeping enough components to explain 95% of the variance. Here, the explained variance per component, the first one had 98% of the variance, 98%. The second one, 1.4. The third one was like 0.2. Here, 0, 0, 0, and so on. So basically, the first component had more than 95%. Sometimes these very small components can be actually very useful. So maybe you can just come back here and basically make that just include the 3 components. Instead of having 95%, we're just going to have 3 components so that we get the first 3 components that have numbers above 0%. Okay. So if you do that, let's just select the all quick so that we can compare the numbers. If we select that and train again, you get improved results. Okay, if you compare these results here, like 85%, 88%, things like that. Here you have 93%, you have 95%, so on. You can increase the number of features. You can have it like 5 or something like that. It's going to keep improving. Basically, I selected another one. Maybe I can just select the or quit the train again. So here it seems like it's basically the maximum is 95%, but actually this is not the best. Basically, when we tried that before, it didn't give us better than 94%. 95%, it gave us 95% here. Okay. So basically, we got the same results. So basically, we got the same results with much less components. When you have a smaller dimensionality in your feature space, when you reduce your features from 13 or more, if you have more features, to 5, it will make things simpler in the implementation. It will train faster. It will be more robust. It's good from every aspect of it. So basically, it's good to use PCA to summarize or to reduce the dimensionality of your problem. Okay, we discussed several options, several other features other than the ones we used. Here we use only 13 features, but actually, if you want to use more, basically PCA would be very important. Okay, because the very small principal components, the ones that you remove or the ones that are like this, having very small variance, like in this direction, basically, they are not very useful. You cannot discriminate. They basically add noise. They are mostly for noise or basically coming from noise. Okay, so this is one of the options that you can try as well. Okay, so this is basically it for the classification learner. Let me show it to you again. I'm going to start another session. When you start another session, it's going to delete everything here, which is fine. I'm going to select the input. Here, the input, the data, I already ran the program that we have before, and I know that the training data or the learning data is in X and Y. Okay, so basically I can come here and select the X. And here I have the response from Y right there. I can choose the classifier validation. I can here try to make it a little bit larger, like 10, for example. Let's see what happens. And we start a session. You can choose from any type of classification you want. Here, for example, I can choose whatever. I can choose maybe the quadratic SVM, for example. Okay. I can select the classification cost the way I want. Here it's 0, 1, 1, 0. It's up to you to choose it, but actually whenever you have the false negative higher, it's actually better. You probably want to have the sensitivity a little bit higher or has more weight. The error in this box, or in this case, in the false negative box, is more critical than the error in the false positive one. Okay, so basically you can either make this 2 and this is 1, or you make this 1 and this is 0.5. It's up to you. So basically this is one of the things that I should do. I can have the PCA also. I can decide if I want to use it or not. Just tick this box right there, and after that I just train. The accuracy is 98%. Okay, I can get the confusion matrix. If I already have it here as a tab, it's going to be right there. This is actually excellent because the true class is 1, the predicted class is 0. So basically, this is actually almost perfect. This is basically all the errors are in the false positive, not false negative. If I look at the ROC curve, here, basically the sensitivity will be 100%, the specificity will be 96%, which is excellent. This is the kind of thing that I would like to see actually. The classification that has very high sensitivity and the specificity is not much lower than the sensitivity, which is really good. Okay? So basically here it's very important to have the positive class. Basically, if you want to have it the right direction here, just have the positive class is 1. So basically, if you do it like that, you can see it very clearly right there. this is 0.04, which is 1 minus the specificity. So the specificity is 96%, and the sensitivity is 100%, because the true positive rate is the sensitivity. You can export these to figures so that you can save them and use them in reports. You can generate the function that you can use for your training. It's right there. It has all the options right there. Okay, you can just copy it and paste it in your code and use it. Do you have any questions? Okay, if you don't have any questions, for the assignment 3, I try to make it as simple as possible. You try to solve the same problems. Basically, it's going to be exactly what we did this lecture or the past 3 lectures. Okay, for the statistical classification, what we did before, the system that we developed. But you're going to have to come up with a new feature so that I can see that you can actually implement something different, something new. Okay. And basically, you're going to submit that as a report, okay? And basically, you want to have a maximum number of features in your system as only 5, okay? Basically, you can do that based on what we did before in the t-test. We said that we can get the minimum p-values. We can see the p-values of each one of the features and get the minimum, or you can basically get all the features that have p-values below 0.05, and then you can do PCA. Okay, so that you can reduce the number of features to 5, basically. But this is actually using the classification learner, of course. Here you want to use a new classification method that was not given in class. Basically, we use SVM in this code. We use SVM, we use the KNN. In the classification learner, you have all kinds of classifiers. Just use one of them, choose one of them and try it, and basically implement the code of it inside the code, the code that's going to use for your system, basically. Okay, you're going to implement that with the same way we did it here. Just get the classification function that the training function here, and just use it inside your code. So this is the new one. Compare at least 3 different classification methods. You would like to compare for example, KNN versus SVM versus discriminant analysis, for example. We're talking about performance, talking about accuracy, sensitivity, specificity, and performance metrics that we talked about, basically. And basically, when I say compare, you have to, at the end of the comparison of numbers, when you have the table, you have to say which one, in your opinion, is better. Okay. For example, like the example we saw, we have several classifiers that gave us 98%, but one of them had 0 false negative. This is better. I would say that this is better than the other one. Okay. When I say compare, you don't have to listen to what I prefer, okay? Just write whatever you think. And there is nothing wrong with that, okay? You cannot have your opinion, you cannot justify something, and basically when I ask about your opinion, basically give me your opinion justified, and this will be it. You're gonna get the grade, okay? You're not gonna be asked to come up with whatever I have in my mind, okay? It's not like that. Just learn how to come up with your own opinions or your own decisions, or when you compare things, you know how to basically settle on the best of them based on a criteria or criterion that basically you decide yourself. Okay.
Doctor?
Here we're going to, yes.
General comparison or according to their performance in my code.
I'm not sure. Basically, you compute the sensitivity, the specificity, these things, and just for each one of them, and compare them. Compare the numbers. Just have a table that has all of them.
Okay, thanks.
And then decide based on whatever you have, which one is better in your opinion. For example, if you have 2 classifiers that have the same accuracy, but one of them has a higher sensitivity and the other one has a higher specificity, okay? Which one would be better, okay? Just give me, basically you say that this one is better because of this, because of, I think it's, you know, because I think it's better for this reason, okay? Give me the reason that you think this is better, and that's it. Here, if you remember this part, the ratio of the data set division between training and testing, the code that we have, our code right there, what we started with was this division right there. We decided that the number of learning cases would be 0.7 or 70% of the number of images, and the testing cases will be 30%, okay? If you change that, would that change the results? Or just give me the effect of that. How, whenever we change that, what would be the effect on the system? Okay. In order for you to do that, it's a good thing to have a larger number, a smaller number, and compare the three values and see. You compare them basically also with the accuracy and the sensitivity, all the performance metrics of your choice. Okay, and give me an answer right there. Which one would be better? Okay, or basically how we can go about this, how we can go about the selection of the division factor. Also, compare the performance of the system when the ROI size is changed to 16 by 16 or 8 by 8. How can we do that? The ROI right now is 32 by 32. How can we do that? This seems like a difficult question, right?
Resize.
This one here, how we can change the ROI size?
Resize.
Resize. Actually, resize is a very good, very nice idea. Actually, you can do that. Resize is definitely right. But actually, what I wanted is instead of basically using the data that I gave you, you can actually resize it and not resize it, just get a part of it rather than the whole thing. Let me show it to you how to. We have here ROI-N and ROI-A, okay? What I can do here is just say ROI, let me just put here N ROI, I'm going to set that. N ROI is equal to 16, for example, okay? What I can do here is select all cases and 1 to 16 or 1 to N ROI, 1 to N ROI. What would that do? Basically, I selected from ROI-A, from ROI-N and ROI-A, I selected all cases, but actually here, instead of using from 1 to 32, I use only 1 to 16 and 1 to 16. If I do that, I keep everything the same. This is going to work. Give me results. But now the ROIs that were used were 16 by 16. If I go back here and change that to 8, basically it's going to select 1 to 8 and 1 to 8. This is better than resize because of the fact that basically I'm taking these ROIs from images. I don't want to change the images, okay? I don't want to change the characteristics of the images because basically I want to decide if I want to move, because the ROIs here would be used later on by just selecting these ROIs and sending them to the CAD system to get classification, and then basically display the results for the whole image, okay? If I do the resize, then I did something that wasn't really in the image. The thing that I get after the resize will be a little bit different in characteristics from the original image that I have. So basically, it's better to do it like this. I just here, instead of using the whole ROI, the ROI size was like this, basically. 32 is like this. basically in the 16 by 16, I selected this. So basically, this is the case, the first case. The 8 by 8, I would select this. So this is basically the 8. This is the 16. This is the original 32. Okay, this is what I did actually in the code. So you select 1 to n ROI. Okay, it's going to be like n 1 n ROI times n. This is the dimension in x, and this is dimension in y. So basically, they are very simple. Basically, all the questions I have, if you think that the question would require a lot of work, then you didn't understand the question properly. Okay, so please ask me if you have any question about assignment 3, please. Okay, if you have any questions, just let me know, and I can arrange for a meeting, or I can send you the answer by email or whatever. Okay. Do you have any question about the first part? This is actually basically, if you sit down with the code that you have from the lecture, you can finish that in about an hour. I expect that. It doesn't take more than that if you know what you're doing. But probably the report will take a little bit more time just to get the results and put them and write your opinion. But the actual coding and actual results, getting the results actually will not take that much time. The second part will be basically using whatever we did last time with the deep learning systems, basically. Okay, so you should choose one pre-trained network, AlexNet, GoogleNet, VGG16, whatever. Just choose whatever network you want. Okay, and basically you have to modify it as we did last time. You remember last time we had to choose, we had to change the last section, the classification part. Instead of having 1,000 different classes, we needed only to have 2. And basically, we needed to change the classification layer and the layer before it, which was actually feeding that 1,000 classifications to the classification layer. So basically, we have to basically make modification. You have to do that to whatever network you have. Did any of you try that after last lecture? Okay, no answer. Okay, I assume that you did. Okay, that's fine. If you have any problems, basically you can review the lecture or ask me. And if you remember that in the training part, we had an interface that had several options, like the type of solver, the initial learning rate, things of that sort. You have several options. What I want you to do is, in order for you to understand what each one does, just try 2 values, 2 different values, and compare them, just to understand what these stand for and what their effect is on the data, on the training, on the network, things of that sort. Okay? So basically, all these things are parameters that you set in the training options. And just make sure of that, because you don't want to basically, if you want to optimize, it's endless. Basically, you cannot reach a stage where you can say that this is the best. You cannot say that. You compare the performance with and without data augmentation. If you remember that the interface, maybe I can just open it. The interface that we had, basically, whenever you import the data, it allowed you to choose several options regarding data augmentation, just using the data with different ways, basically. Let me show it to you. Okay, let's just choose any one of the existing ones. Show more. Maybe just choose that. It's actually in the data tab here. It's not in the designer. If you remember the first part that I was telling you about the optimization, just click on this one here and use Control Plus to amplify. Remember that we had to change this one here because it has 1,000 outputs, and this classification layer, it has 1,000 outputs. So basically I have to remove that. I have to remove that. And basically get one from here, drag it and drop it here, and look for a classification. Where is the classification? That's classification layer right there. And then connect everything. If you don't connect any, if you forgot to connect one of them, actually it's going to give you an error in the training. So just this is basically the modification, that's customization we made to our problem. Here you have to import data, and basically you can choose it from a folder. Basically like the data I gave you, it has to be a set of images, and they are placed in a folder where you have the number of classes or the classes that you have as separate subfolders, like normal and abnormal. You have images of the ROIs within each folder. So basically we choose that. The augmentation here basically does random reflection, random rotation, random rescaling, random horizontal translation, random horizontal vertical translation. These are things that are designed to make the training a little bit more robust. Because basically when you train with a particular ROI, if this ROI is rotated, it should give you the same result, okay? It's like having a problem, an engineering exam question that was slightly modified, okay? If it's slightly modified, if the student doesn't understand the problem, if he basically memorized the solution to a very similar question, if the question is slightly modified, he will not be able to do that. He will not be able to solve it. When you train him with slightly modified version of the same problem, then he will get basically better training and get better at solving these problems. So basically you want to try that. You want to try random reflection, basically it's reflection, meaning that it's mirror image. You get a mirror image of the same ROI with respect to X or respect to Y. You can have random rotation from, for example, minus 180 degrees to 180 degrees, for example, okay? Whatever, okay? Random rescaling making the ROI bigger or smaller. I'm not sure if that would help, but actually these kinds of things, I want you to try a few of these options and basically just give me the impression you got after you use them. You don't have to try each one of them separately because it will take time to train deep learning networks, but just try with and without augmentation and let me know your conclusions. Is that clear? Basically, here you have different percentages. It's exactly in the same part here in the import. Basically, you choose the validation data. It's exactly the same as the one that we have been talking about. Basically, you split the data into training and validation. Basically, choose here 30% for validation or testing. Basically, validation here is like testing in the statistical classification. So if you choose it as 20% or as 50%, basically, you want to see the impact of this choice. Okay? So this is very important. Okay, so just choose a couple of values and basically compare them to what you got with the default value and let me know your opinion or your conclusions, okay? So this is for assignment 3. Do you have any questions about assignment 3? Okay. For the research exam, I don't expect you to, basically all these are intended to be new problems that you probably didn't see before, okay? The point from a research exam is not to make sure that you know exactly what you're doing here. I just want to see if you can generalize what you saw in the course to other problems. Okay, if you answer each one of these problems in any way, just give me your opinion, you're gonna get the full mark. Okay, I'm not gonna say that this is correct and this is incorrect. No, I just wanna see what you came up with based on what you learned from the course, you know, as applied to these problems. So basically in these questions, I would like you to understand or to work on whatever you see here, okay? You don't have to ask me exactly what I mean by this. Just solve whatever you understood from the question, okay? The last part here is I want you to have a brief research proposal that has 4 components: clinical problem, suggested approach or methodology to use, available real data sources, and the performance metrics that should be used. Basically, I expect this to be very brief, okay? So for example, I can say that the clinical problem would be basically classification of skin cancer images, for example, okay? The suggested approach will be, for example, statistical machine learning or deep learning, for example, okay? Available real data sources, just search the internet and find a database for the problem that you choose, okay? This is very important. Basically, this particular problem is really practical because this is what you will be doing actually when you're going to start, whenever you want to start your thesis. At the end, the performance matrix, how can you judge the results that you're going to get out of your methodology, okay? Like for example, in the, if you want to have mammography, computer-aided design, you want to look at performance metrics like the accuracy, the sensitivity, the specificity, things of that sort, okay? So basically just choose whatever performance metrics. For other images, for other problems, there might be some other performance metrics. These will have to be researched over the internet and just give me your results. Be sure that if you answer these questions, if you answer them, just give me answers. I'm not talking about correct answers, just answers based on what you think, based on your opinion. You're basically gonna get the 15 marks. This is 15% is 15 marks, okay? You're gonna get the full mark, okay? So the research exam is just a way for you to understand whether you can generalize the material that you have in this course or not, okay? So do you have any questions? I need to emphasize that the deadlines for these 2 assignments, assignment 3 and research exam, are firm. You have to really finish by that deadline because I have to submit the grades by a deadline, and it's very important, you know, that I do that. Okay, so please adhere to the deadlines that are presented in the assignment on Blackboard. Okay. Do you have any questions? Okay, if you don't have any questions, basically we're very much done with this lecture and this course. Okay, and I hope you basically benefited from what the topic that we had. They are definitely, you know, generalizable to other problems, and this is the most important target of this course. If you have any questions from now until the end of the term, please feel free to contact me by email, by WhatsApp, whatever means. If you even need to have a meeting, I can arrange a meeting on Zoom, and I can meet with you if you need to. The thing I want to emphasize is that try to do things based on what you understood from the question, okay? Don't try to make it difficult for yourself, okay? If you ask me about, basically later on, if you ask your advisor in your thesis, if you ask him that I have 2 ways of doing this, okay? And this way will require more time, and I probably have to go somewhere to use a computing resource and so on and so forth. And the other way is very simple. I can do it on my laptop, and it will take me about an hour, okay? It's very likely when you ask your advisor this question, he will tell you that, you know, it's better to do it the other way, the more difficult way, okay? So basically, don't ask questions that would make things difficult for you up to your colleagues, Okay, so if you ask me if I want to try different deep networks, okay, I'll tell you yes, sure. You just tell your friends to do that as well. Okay, so basically, when you ask a question like this, you will have more work to do, and you actually, give your colleagues a present of more work, based on the answer to this question. So just, work on whatever you understood from the question. Even if I wanted a little bit more than, than you did, if you understood it correctly from the question, that's fine. I will respect what you understood from the question, because sometimes the same question can be understood in different ways. So simplify, okay? Don't try to do things or overdo things, okay? And I wish you all the best of luck, and I hope all of you will get the A+, okay? If you submit your assignment 3. And assignment 3 basic, I hope it will be at the same level as the other 2 assignments, and submit the answers to the research exam. I believe it's very difficult for any of you to not get an A+, okay? So I hope you continue your excellent work in these remaining tasks, and please let me know if I can help. Okay? Any further questions?
Doctor, I just wanted to ask.
Yes, go ahead.
Shawan, you never gave us feedback.
I didn't hear you correctly. Can you say again?
I just want to ask for the research one. We submit the research one. We share it with your email, but you never give us any feedback.
Actually, you have the grades and you have the comments actually on Blackboard for all the assignments that you submitted. Can you check it on Blackboard? If you click on the grade itself, you will see my comments actually. But all of you did very well actually in the previous assignments. But all the assignments that you submitted had feedback with the grades for individual parts, and some comments if there are any comments. It's already in Blackboard. If you couldn't find it on Blackboard, let me know and I will share it with you by email. Okay? Just go to the Grade Center and you will find it there. I can show it to you, for example. I can go here, Grade Center. Not need reading. Need reading, nothing. I graded everything. So the Grade Center, right there. Oh, you mean this one here? But this one here is already 100. So. For example, here I can see the attempt. When you look at this right there, basically, if I stand here, you'll see the comments right there. The comments are right there, okay? You can actually look at it there. My comments are basically on each part, basically the grade and the comments if there are any comments. This part right there, okay? For the for the basically, this is what I have here. I'm not sure if you submitted something different, but actually it's already 100. Here when you have, this is the old one here. This is old. This is the last one. So basically it's the 100. You don't need to have that. Basically in all of them, basically you have the, when you have a one that looks like this, basically it's the old submission. So basically, it's not really gonna be. It's not gonna appear here. So just let me know if you have any problems, basically. Okay. If you have any problems accessing my comments. Okay. Okay. So So I think if we don't have any further questions, then I'll wish you the best of luck, inshallah, and see you next term, inshallah. Okay? Assalamu alaikum.
Wa alaikum assalam.